Hello everyone, my name is Suryan Chambegar and today I'll be talking about SCADA. SCADA stands for Supervisory Control and Data Acquisition. In simple words, it's a computer-based system used to monitor and control industrial practices. It's widely used in industries like power, water, oil, gas, and manufacturing. The main importance of SCADA that it reduces human error, improves efficiency, and ensures safety. Instead of more workers manually checking machines, switches all the time, SCADA helps to monitor everything automatically on a computer screen. This makes industry faster, safer, and more reliable. Now let's look at the basic architecture of SCADA. Think of it as a chain that connects machines to humans through technology. The first part is field devices. There are things like sensors, actuators, meters, and switches. They interact daily with the physical process. For example, a pressure sensor can measure pressure in a pipeline and send that reading forward. The second part is the communication devices. They act like middlemen. They transfer signals and data and from the field to the main control center. Depending on the industry, these may include wired networks, wireless systems, fiber optics, or even satellite links. Without communication devices, the information collected by sensors would never reach the operators. The third part is the SCADA master station, also called as the control center. This is like the brain of the whole system. It has servers, softwares, and HMIs. Operators sitting here can see real-time data on the screens, give commands to the machines, and store historical data for analysis. So, in short, the architecture works like this. Sensors gather the field raw data, communication devices carry the data forward, and the master station processes it into useful information. This smooth flow makes SCADA the backbone of automation. To understand SCADA better, let's take an example of a substation automation. At the process level, which is also called the field level, equipment like transformers and circuit breakers do the actual work. And sensors known as merging units collect values such as voltage and current and convert them into digital signals. At the bay level, intelligent electronic devices, also called as IEDs, receive this data and they act like a local brains. For example, if there's a fault in the system, the IED can immediately trip a breaker without waiting for human action. They also send processed data further to the control center. At the station level, which is the main control center, an Ethernet network connects everything together. SCADA server here collects, processes, and stores the data. Operators see all this on the HMI, which is also called human machine interface. This is basically the dashboard screen. From here, they can monitor and control the entire substation in real life. So, the flow is monitor, analyze, and then control. Data goes up the chain for monitoring, and commands flow down for control. That's how SCADA measures substation automation runs safely and efficiently. So, let's talk about the real life application of SCADA. SCADA is not limited to one field. It is used in many real-life applications across industries. Take electric vehicles for example. Electric vehicles need charging stations. Charging stations with growing number of EVs, it's important to monitor charging points, manage power demand, and prevent overload. SCADA helps operators track each charging station in real time and balance the load across the grid. Next is smart cars and intelligent traffic systems. In modern cities, SCADAs help integrate car data with traffic lights and road sensors. This helps in reducing traffic jams and improving road safety. Another application is satellite and space stations. Here, SCADA principles are used in ground control systems. They constantly monitor the health of satellite, energy usage, and the communications links. Without SCADA-like systems, managing space missions would be very difficult. We also see SCADA concepts in robotic prosthetics. These devices need sensors to capture signals and control to respond immediately. A SCADA type setup helps ensure smooth coordination between input sensors and motorized movement, giving better control to users with their prosthetic limbs. Apart from this, SCADA is widely used in power generation plants, oil refineries, water treatment plants, and manufacturing industries. Basically, any system that requires continuous monitoring and control can benefit from SCADA. So, just now we discussed about applications of SCADA. Now let's discuss the benefits of SCADA. The biggest benefit of SCADA is centralized visibility. Operators can see the whole process on one screen and it quickly detects problems. It reduces downtimes, ensures safety by giving alarms and alerts, and cuts cost by reducing the need for manual work. SCADA also stores historical data. This data can be used for planning and decision making in industries. Overall, SCADA improves efficiency, saves money, and increases safety. To conclude this PPD, SCADA plays a vital role in process automation. It connects sensors, controllers, and communication networks and operator interfaces into one complete system. It converts raw data into useful information and gives operators the ability to act in real time. From power grids to water treatment plants, SCADA has become the backbone of modern industries. It makes processes more reliable, efficient, and safe. Thank you.